Welcome, I'm Blair, and today I'm going to talk about how I automate with AI. But first, a bit of background. I'm currently the AI lead at SureSpan Construction, where I oversee the responsible application of generative AI. I graduated from the University of Victoria with a master's in applied science and civil engineering, where I studied the application of machine learning to building optimization and building energy. I have a lot of experience in design and engineering studios, and I'm really very proud of that experience because it really taught me to be a creative problem solver and really built up a strong skill set to attack multidisciplinary collaborative problems that you see in practice. This meme I made sort of shows how I sort of think of current industry. It's very reflexive, and they just want to put a chatbot on it. They see something, put a chatbot on it. And as we go through the projects in this portfolio, you'll see a very unique and novel ways of applying agentic pipelines. One of the major characteristics of these projects is one of scale. I get really excited about processing data and enriching data, and dragging PDFs into the browser is simply not an option at scale. And I really love what I do, and so I want the excavator, not the shovel. I did want to touch on some important definitions that we'll sort of use throughout this presentation. And one of the distinctions I make is machine learning training versus agent memory. A traditional ML is kind of like the left side of that image, this kind of still frozen garden. Traditional machine learning has a lot to do with updating weights, but they become very static. They're great at finding sort of deep patterns, but ultimately the knowledge is very baked into the model. Agent memory, on the other hand, which sometimes people do talk about as being training data, but agent memory is something that's very dynamic, and it's like that library and workshop on the right-hand side. It's something that can be updated easily and is a really lively part of building up a context that you can make very advanced inferences from. And this is a very important distinction if you're trying to tackle problems with LLMs. Another important distinction I make is between prompt engineering and context engineering. They're very similar concepts and they're often used together, but this distinction is really important when you're trying to solve problems with LLMs. Prompt engineering is sort of trying to elicit or prompt very explicit behavior. And context engineering is sort of building up sort of this context, this foundational knowledge that you can reason from about new things. I really think of it kind of like a barista. If I just go into the coffee shop and order a coffee, that's like prompt engineering. Context engineering is that barista sort of looking through different facts that I normally come in at a certain time every day, maybe the current weather, the time of day, and sort of putting those things together to infer that when they see me, they can just start getting my drink ready. And that's sort of an important distinction between prompt engineering and context engineering that I use all the time. Before we get started on the case studies, I just wanted to mention that I kind of imagine them like this dashboard. They're really complex. They have all sorts of buttons and dials to fine tune. And I can't really mention all the different parameters in this overview. But if you do have more questions of why I didn't do this or why I did that, often it's kind of the universal answer of it depends, but I'm certainly available and would love to talk more about some of the details. So my first project out of grad school, where I had this excellent background in machine learning, was to immediately pivot to large language models. Here, I think the client did a really good job identifying a particular pain point that was rather low risk. It wasn't something that ran daily, but rather quarterly. But the client wasn't happy. They had sort of this portfolio of buildings, and they were trying to generate this quarterly embodied carbon report or this building energy report. And it was taking business analysts and project managers 80 hours a quarter to develop this report, which is quite a lot of hours a year. And this was a really good well-scoped project to implement. We had a good set of historical reports as well to work off of. And so what I did is I just sort of wrote this agentic pipeline that different agents wrote different sections of the report First, it would go and sort of collect some data or some time series or some tickets for the period under observation, write the section, and then we'd sort of look at the previous reports and then build up an introduction and a conclusion. It was really a success. Just comparing the historical data to the output of this pipeline, it was virtually indistinguishable. I actually say it was higher quality and saved up to 320 hours every year of business analyst time. And this was a really successful project and is still in production as far as I know. I haven't kept up with this project, but yeah, a really big success. My second project was a project at UBC. Building there was expanding, and of course it was going to be a smart building. And what better to go with a smart building than a building performance concierge? I thought this was a really cool project. As the building wasn't built, we were using sort of synthetic data or sort of data that was other buildings had generated. We were still sort of building out that tool set and that pipeline, but it would take things like building energy logs, maintenance tickets. It would digest a whole bunch of HVAC manuals, and a chat agent would have access to all this knowledge, and then it could respond to users' request. This was looking really good. It was quite complex, and the chat agent was working really good to sort of, again, surface really important data points that could be very helpful to users. This project was eventually suspended for lack of funds, but I learned a lot and really showed a lot of the potential of how you can use tools to build up knowledge to respond to users' requests and like surface really important data points. I think this project shows really well the power of using LLMs to enrich data. It's really amazing to me that even though the accounting of dollar and cents is so well tracked, certainly in regards to transportation, what was transported, where it was transported to, how it was transported is all detached from that accounting. And it is there in the invoices, but that can be an extremely noisy data source. And this was a real pain point because as executives and senior project managers are on the phone trying to find transportation costs quickly, they'd have to like dig into all these deep in these project folders to try to like think about this quote they once got. And we needed to simplify all that. The data was right there, but it needed to be reconnected with those costs. So we used multimodal LLMs to clean about 7,800 PDFs. I think it was about $10 was the final run. But we were able to ultimately reconnect what was transported, where it was transported to that cost, and also subsequently add more columns, enrich the data more with LLMs. And so it gave us several outputs. We were able to visualize the data set in certain ways. We were able to create a predictive model with the origin and destination and the route distance. But ultimately, what we found most helpful was actually deploying this clean data, this knowledge, to a conversational agent. And that means that an executive, instead of having to dig through a project folder for a certain price he thought might be there, could just chat with this transport cost analysis agent on Teams and just sort of get all this data about this route just sort of bubble up automatically and some of the characteristics of the route. And it's taken things from minutes to seconds and getting some important data points to make decisions about. When I started at SureSpan, I came into a very chaotic situation in regards to project estimation. About 20 people all over the company every morning were looking across websites for potential work. And these were really expensive people that were just looking at websites, and a lot of them looking at the same website again and again and again. It was a lot of overlap work. And so the first thing I did, and this is currently in OpenClaw, but OpenClaw goes out to a whole bunch of different sites and collects the bids, and then we bring them in-house and just work on them in-house. The real secret sauce here was asking an LLM to then look at that potential project and sort of ask it, like, how well does it match the characteristics we want to pursue this sort of bid with? And that it's worked really well. This is something that we watch very closely, and it's been amazing to see the amount of nuance these LLMs can actually have in regards to such sparse amount of information. It's been really wonderful. But basically, after looking at any new bids, we then put together a summary of summaries and email them out before the workday. And so this is something that usually they could start working on bids, around noon. But now to have that email right at the start of the day, everybody was happier. And it was really amazing to see that we were able to hit the pain point so perfectly. There was no change management. There was no cajoling or persuading people to use this tool. It was just evidently better, and it was the uptake of it was really natural. And right now, this has processed tens of thousands of bids, and it's a very robust piece of software. Site reports is another sort of laborious task that a junior project coordinator or a junior project manager would sort of do. They'd sort of look at the previous day's site reports and collect and aggregate them in different ways to sort of surface important details. Again, if someone's sort of making if there's a big accident on site, of course, someone's going to phone in to the headquarters here. But this was a really good low-hanging fruit that we could use LLMs to automate. So this sort of looks at yesterday's site report. It also looks at this rolling window of previous site reports, and it does some different inferences on it to find out production rates or if there's any sort of anomalies in regards to some scheduling information we've given it. We do some more transforms, and we sort of create a LLM summary of summaries, and then we send it out as an email. So instead of getting the information sort of around noon, again, now we're sort of seeing yesterday's information right there at 7 a.m. in the people's inbox, and this becomes immediately actionable for all sorts of different things. And again, this is like really gratifying to see, because if it's not working, people are knocking on my door about where it is. People have complaints about it, so I know it's being relied upon and used to make better business decisions. Now is a good time to pause for some important takeaways. The first thing I wanted to stress was the importance of prompts. You've probably noticed there are no direct references to prompts in this presentation. I work directly with executives very hard on these deliverables, and it really makes the prompts very sensitive digital assets because we put so much time and energy into them that I'm not comfortable showing them here. The second is the importance of validation. I really don't think you have a generative AI program if you're not doing validation. All the agentic pipelines I'm showing in this presentation all have very advanced validation modules attached, where we can run the same data set through again and again and again. It allows us to measure variance and drift of our agentic pipeline and be able to talk with some degree of certainty about the uncertain aspects of these pipelines. Before you can ever estimate a project, you have to know what a project is. And tender document packages can be like really large and really noisy. And leadership needs to know certain data points really quickly to make good decisions about whether the project should be pursued or not. And so this does all sorts of different extraction and of text and images to make sure it's in a form that LLMs can then make more advanced inferences about. And this gives you sort of an overview of how we sort of distill the semantic meaning of attender documents. Some highlights are that QTO agent. That is how we sort of attack construction drawings in particular. There's quite a lot of model controller logic that goes there. We want to make sure that as we extract things from the construction drawings, that we're using a model that's scaled to the challenge of its extraction. And so this sort of will only bump up to a higher, more powerful reasoning model if it's really if there's a lot of uncertainty about the item's extraction. And that's one way that we can optimize tokens. Another way that we optimize tokens is that master takeoff tries to more directly replicate human work product. And there we've designed it as a harness. It's just an agentic loop that it can sort of decide on its own when a certain page of the takeoff is complete and it has enough certainty about it. And that's another really good way to optimize tokens in these systems. Right now, this is something that's in production and runs every day to make sure that what used to take probably 2 or 3 hours now takes like an hour to get those data points. So the last slide is sort of at the top of this side. We build our estimates up much like a human estimator would, and that's with a work breakdown structure. And we use those work breakdown structure items to like item by item build up that estimate. We have a very good idea of what's in semantically in the tender docs and what's in the project. And it's just a matter of then making sure it's in scope. And then we also use a swarm to do multiple predictions of the same work breakdown structure item. And this really reduces the variance we see in the estimate and brings us much closer to the real predicted amount. After that, we have to condense and sort of reduce our uncertainty about certain items. And then there's a refinement layer where we use the largest model possible and look for overlap or gaps that we missed. And there's all sorts of output and different types of reporting that come from this layer. And again, we're really reducing something that would normally take, just to get a ballpark estimate, 2 or 3 days. We're condensing that down to an hour, and it makes us much more nimble about what we want to pursue, and already we have like a framework and structure of normal estimate materials already started for users. Validation, again, super important. Here, the estimated cost is not in our agent memory of project histories. That's just the context to make an inference from. And so we have to make sure we're calibrated and that we can measure the uncertainty. And so we use a set of 14 human estimated projects that are not part of the project history to be able to measure that. And that data set and those measurements that we're constantly doing allows me to speak to the uncertainty and how we can really trust these numbers in a business sense. This is a bit of a bonus slide about how you can process over 25,000 project documents. It's a very noisy environment. And so I developed a whole Python-based silly application to do just that. Certain project files we sort of process in bulk. Certain project files are very specific, and then we have sort of specific data processing pipelines in this application that process them. But ultimately, we exercise great care in making sure that text is cleaned and normalized to the best of our ability, so that we're giving a nice, clear signal, a nice, clear context to the LLMs to make good inferences from. And so it takes a lot of effort to really make that a repetitive, predictable thing. And so here we have different data sources, and we sort of use that silver, gold, agent memory staging so that we can repeat certain stages independently. And this has been a real pleasure to work with, and I'm quite happy with the quality of the vector store, which has a little bit over 350,000 vectors in it currently. So is all that effort worth it? And that's what having like a robust validation process shows you. Here we have a comparison of a naive approach, which is just that work breakdown structure and a project summary dumped into Copilot, and we ask the Copilot to just fill it out, versus the output of our agentic pipeline. Our 2025 pipeline results are on the left, and our 2026 results are on the right. And what this shows is that our agentic pipeline is better than a naive one-shot. You see our agentic pipeline is much closer to those thick lines, which represent a human estimated direct cost, and much tighter, less variance than multiple naive runs. Finally, I just wanted to touch on some of the tools that I use to make these agentic pipelines. Llama Index is great for document processing. Ollama we use for hosting local models. Of course, Azure and AWS host our LLM endpoints. Docker for some of the automated work. Having lots of fun with OpenClaw. I work in Python, R, C#, and I'm trying to work more in Rust. Hugging Face has, of course, all sorts of interesting transformers that I use at various points in these pipelines. And of course, for memory, for agent memory, you have pgvector, SQLite, LanceDB is not on there. All like really helpful products when you're trying to make an agent memory. Thank you so much for watching. I know I talked a ton about generative AI, but I wanted to share here some of my intermediate materials. I drew all these images by hand. It's absolutely a pleasure to sort of educate and entertain with humor and images. Thanks so much.